Welcome everybody. You're watching a 5-minute crash course on the practical CDN caching for developers. And yes, that's little terminal line at the top which says X cache hit. That's exactly what we're chasing today. That response header is your proof that your CDN did its job and your origin server did not, basically has to wake up. Everything in this video is grounded in the RFC 9111 standard. That's a HTTP caching standard which was dropped in 2022. So this isn't an opinion, it's a spec. So let's get into it. So what is CDN caching and why should you care about it? Simple idea, instead of every user's request traveling all the way to the origin server, a CDN stores copies of its content on all the edge servers placed physically closer to you all around the world. So the diagram here shows exactly that flow. The magic number on the right is actually 95% plus is a number that every system wants to achieve as a cache hit ratio. So that's a benchmark any healthy app should be hitting at the edge. And look at those 4 benefits: lower latency for all the users globally, and it also protects your origin server from traffic spikes, and it also improves the reliability and also the cost if you think in that. And there's a small footnote which I have added. That's my favorite reality check. If your origin traffic doesn't drop after enabling the CDN, the configuration is probably wrong. Before we get into the directives, let's zoom out a bit. All of the HTTP caching is really just 3 concepts. RFC 9111 from 2022 is the spec that defines all of it. First one is cache headers, next is TTL, next is caches, cache keys. For cache control and e-tag, vary. These are basically your control surface. They tell every cache in the chain who is allowed to store a response and for how long. Next, let's come back to TTL. So freshness is a priority chain, right? So S max stage is actually wins over max age, and which wins over again expires. So go aggressive on the static assets, conservative on anything dynamic. Next is cache keys. So it's a host plus path plus query. So treat it like an hello list kind of a thing. Every dimension that you add will fragment your hit ratio. So having lesser cache keys is actually more efficient. Quick warning before we move on. There is a vary wherein people usually pass either cookie or user agent. So basically this explodes your cache into multiple variants and tanks your hit cache ratio. So only use vary for content negotiation like accept encoding, not for everything. Alright, so HTTP caching is one of those things that make or break your app's performance. Yet most developers only really use maybe two or 3 of these directives that I'm showing right now. Today I want to make sure I walk you through all the 7 that usually matters, because like if you master this, then you can easily handle that benchmark that I was talking about, 95%, right? So max age is equals to n and S max age is equals to n. So let's start with these 2. So max age is equals to n is your general freshness timer. It tells every cache in the chain, the browser and CDN alike, how many seconds this response should stay fresh. Now let's come back to the S max age. This is surgical override. So that S, whatever small s you are seeing, it is a shared cache, meaning all the CDNs and the reverse proxies. So if you want your CDN to cache something for a day, but the browser to refresh every 1 hour, then probably you will set something like, hey, max age equals to 3600 and S max age equals to 86400, which is probably a day in seconds. Super useful when you want your edge to cache longer than the browser. Now let's come back to the next one, no cache and no store. But here is where the people usually kind of trip up. I mean, constantly no cache does not mean to do not cache, right? Terrible naming, I know that. What it actually means is that store the response, but before you serve it again, please go and check with the server if that is still valid or not. So it's like saying you can keep a copy, but always ask me first. Now, coming back to no store is the one actually that kills the caching entirely. So nothing is written to the disk or memory. Use that only for sensitive stuff like banking pages or probably auth tokens or anything that you never want setting in a cache anywhere. Next one is private. Private is simpler. It means just a browser only. So your CDN skips it entirely. So this is exactly what you want for your personalized responses. A logged in user's dashboard or profile page, the shopping cart. You don't want that stuff to be cached at the edge and accidentally served to somebody else. Yeah. Next, immutable is beautiful. In its simplicity, you are actually telling the browser this file will never change. Don't even bother revalidating it during its freshness window. This is perfect for all the versioned assets. So whatever you're seeing, I'll show that in the next, probably next slide. But yeah, Last one, this is my personal favorite for anything dynamic content. Stale while revalidate. Here is the idea. So when the cache response goes stale, instead of blocking the user while fetching a fresh copy, you serve the old one immediately, zero latency basically, and refresh it in the background. The next user gets a fresh version. It's a massive win for anything, perceived performance on things like, newsfeed, product listings, or dashboards. Now let's make this practical. Think of every root in your app as belonging to one of these 5 buckets. The bucket tells you exactly which directive to use and what details to use. All the JS, CSS, images has the file names set max age to a year, probably with immutable things. That chip at the bottom, which I'm showing a file name, is exactly what it looks like. Zero validation, maximum cache hits. Next, HTML files. These are basically opposite. This should have only shorter TTL, or probably you can say like no cache. And you need to automate a purge in your CI/CD pipeline on every deploy. So you never want users hitting a stale HTML shell, right? Now, let's come back to the anonymous full pages. So public pages with no user data, basically. Cache these at the edge freely. Just make sure you bypass the caching when a session cookie is present. Otherwise, you will serve a cached page to a logged in user, which is not good. Next, coming to dynamic or APIs. So short TTLs plus kind of a stale while revalidate scenario, and include any relevant query parameters in your cache key. Otherwise, two different requests can collide on the same cache response. Next is personalized or auth. Already I explained about this. It should be private or no store, full stop, that's it. Never let user specific data touch a shared cache. This is the one rule you really cannot afford to get wrong. Okay. Now comes on invalidation. You follow this priority order. Content versioning first. No purge needed there. Then the cache tags if you really need targeted purges. Then comes the CI/CD purges. Then manual purging is the last resort only. So basically, if you have to do this way, otherwise it's going to hammer your origin. Now, most caching bugs aren't a technology problem; they're a configuration problem. So here is the 3 I see over and over usually. First one is private data in shared caches. This is a scary one. User specific responses leaking at the edge. Always audit new auth routes before they ship and apply private or no store on them. Okay. And next one is misusing vary, which I explained earlier. So user agents basically fragments your cache into thousands of buckets and basically hits your hit rate. Stick to vary, only accept encoding only, and for per user pages, and don't cache at the edge at all. Okay. Now let's come to the manual purges. So manual purging spikes your origin and breaks under load. Use content versioning and cache tags for 99% of the cases. Manual purge should be your last resort, not the default plan. Okay. Takeaway: private or no stores on auth routes, vary on only for accept encoding, and version plus tag based invalidation. Nail these and you will avoid 90% of the caching incidents. Here is a big takeaway to close this out. Treat cache keys, headers and invalidation as first class design, not afterthoughts. Okay. These aren't DevOps concerns, DevOps concerns that you want to come at the end. They're actually architectural choices that compounds into wins, even in performance, scalability, cost, resilience, and everything. 3 action items to start today: standardized version assets with max age of some value and with immutable. And then think of cache keys as an allow list. Only include what genuinely changes the response, and instrument your hit ratio from day one. Target that 95% plus at the edge. At the CD at the bottom, which I'm showing, curl -l whatever your site.com, check hashkit. Do it right now and check whether you're seeing a X cache hit or X cache miss. So if it's a miss, you know what to fix. Thanks for watching. Like and subscribe for more dev deep dives like this one.